All right, so today we're going to talk about scientific notation. In scientific notation, we're pairing with our exponent rules because when we are multiplying, dividing, or taking scientific notation to another power, we can use the exponent rules we've been using the last couple of sections of notes. So, for example, today the front side of your homework will just be converting from scientific to standard notation, but the back side will be going back to using those exponent rules or exponent rules that you've been using the last couple of notes. So here, scientific notation, what it is a way to write very large or very small numbers in a more compact way. And it's called scientific notation because a lot of times these very large or very small numbers come up in science. Distance from here to the moon, for example, is a super large number, and you don't want to have to write out every digit of that number if you can help it. So, for example here, if I have 3.7 times 10 to the 9th, that means I'm moving this decimal place 9 times to the right, which will give me this large number here, 3,700,000,000,000, which normally we wouldn't want to write all the way out. So that's why we have scientific notation. That's why it exists. And how we get from this to this is by moving that decimal 9 spaces to the right, since we have an exponent of positive 9. Or here we have an exponent of -6. That means we're going to move 6 to the left. And this would be a very small number. So between our decimal and our 4, we have 5 zeros because that first movement is getting on the left of 4. And this is what it would look like. So let's take a look. I've already mentioned this, but just to reiterate, positive exponents means that the number is large. It's got to be at least greater than 1, but usually a lot bigger because we wouldn't take the time to write a number in scientific notation if it was as small as 1. But if you have 10 to the first power, you're multiplying by 10. If you're 10 to the second power, you're multiplying by 100, and so on. If the exponent is negative, that means the number is small or less than 1. So moving down into the negatives, that means you're multiplying by a 10th, by a 100th, by a 1,000th, and so on. So that's why we're moving to the left when we multiply by negative exponents or negative powers of 10. And when we have positive powers of 10, that's why we're moving to the right. So let's do some examples here. We want to write this number in scientific notation. So in scientific notation, I want to reiterate, if I haven't said already, that in scientific notation we want just one digit to the left of our decimal. So instead of 68.7 or 687, I want to use 6.87. So when I'm trying to figure out where to place my decimal, I like to just put an arrow after my first non-zero digit. So my decimal is going to go right in between 6 and 8 here. So I'm going to have 6.87 as my number in front of my power of 10. And again, that's standard. You want this number in the very front should be between 0 and 10 always, which means it has one digit in front of your decimal. And then to get our power of 10, we want to count how many would be after that decimal to the end. So this would be 1, 2, 3, 4, 5 digits. So we want times 10 to the 5th power. Okay, another example, but this time it's a small number, less than 1. So I'm still going to put my arrow after the first digit that's not a 0. So this would be 5.67. And then sometimes small ones are tricky because we're really just counting from our arrow to where the decimal would be, like our decimal would be on the end here. So we're not counting this first 0. So we're counting our 5. We'd have 1 jump here, 2, 3, 4 to get back to my decimal. So we want times 10 to the -4th power, since it is a small number, less than 1. But you don't want to count this last 0. We're counting this 5, 0, 0, and 0. All right, moving the other way, how we take a number already in scientific notation and write it in standard form is I would just move, since this is positive, to the right 5 times. So I'm going to go ahead and rewrite it over here so I have a little bit more space. And this would be 1 jump, 2, 3, 4, 5. So I'm going to have to add 2 zeros. So a common mistake sometimes students will make is they'll add 5 zeros, but that's not always the case. In this case, we're only adding 2 because we already had 3 digits after our decimal place. So this is 849,500, it looks like. So let's try one where we're getting smaller. So this time I want to move 4 to the left since it's a negative exponent. So again, I'll rewrite it so I have a little bit more space. So my first jump is just to move here, and then I have 2, 3, 4. So after my decimal, I'm adding 3 zeros. And you can put the 0 in front of your decimal. You don't have to. I'll take it either way. I tend to because I think it's a little bit cleaner looking, but this is what your answer would look like. For our last few examples here, we're going to talk about whether or not the number is written in scientific notation, meaning that our first number is between 1 and 10, and then it's times 10 to a power. And if it's not, I'll show you how we can correct that. So this first one, 2.35, that's A-OK. So it is in scientific notation. Really what we're looking for here is if there are 2 digits in front of the decimal or only a 0 in front of the decimal, that would not be okay. And this comes up when we are multiplying or dividing scientific notation, because sometimes when you multiply or divide in scientific notation, those numbers will then become 2 digits instead of just the one that you started with. All right. So for this one, what is wrong with this one is we want just the 4 in front of our decimal. So instead of 45, we want 4 and 56/100. So this would have originally been moving 4 to the right. If I'm going to move it 1 to the left, that means I'm actually going to move a total of 5 to the right. If that's confusing to you, you can always expand it out and then put it back to figure out what your exponent would be. But if this is moving to the right and I went 1 more to the left, I need to add another jump to the right. All right, here, similar problem. I have 12 in front of my decimal point, and I only want the 1. I want 1 and 25/100. And how I can fix it is this would have originally been moving 2 to the left. Now I only need it to move 1 to the left. So I have 10 to the negative first power instead. And then last one for this slide. We want this to be 5.6, not 0.56, because it needs to be between 1 and 10, and this would be less than 1, so we want 5.6. And this would have normally needed to move 3 total. Now it's only going to need to move 2, so we want times 10 to the second power. All right. At this point, I'm going to go ahead and do a couple of the backside on your homework with you. If you don't already have a worksheet, go ahead and grab one from me, and we're going to take a look at the back side. So the front side is pretty straightforward from our notes, but I want to do a couple with you from the back so that you can get an idea of what's happening since there weren't any explicitly in our notes. So let's go ahead and do number 1. On the back side of our worksheet, I have 1.08 times 9.3, and let me back up here. I have this number in scientific notation times this one. When it's 2 sets of parentheses like that, it means multiplication. And what you could do is you could expand both out, multiply them, and then you could put them back in scientific notation. But that would take a long time, and it's kind of a lot of work. You would still get the correct answer, so if you're ever in doubt, you are welcome to do that. But I'm going to show you a shortcut. So 1.08, I can take that times 9.3 here. So let's do that. 1.08 times 9.3 is 0.744. And then when we multiply powers, we add our exponents. So I'm multiplying 10 to the negative third times 10 to the negative third. That would be 10 to the negative 6. Negative 3 plus negative 3 is negative 6. Now this is where it could come up that you need to fix something from time to time. Like this, we don't want a 0 in front, we want the 7 in front. So I need to correct this by making it 7.44. And before we would have had to move this 6 to the left, now I'm going to have to move it one more time at 7 to the left since I went to the right one. All right, so this would be our final correct answer. You would not want to stop here. So that's how you would do multiplication, and sometimes they do work out where it's already written correctly. You don't have to fix it every single time. So let's also take a look at number 5. This is a division problem. The fraction bar means division. So I would take my numbers in front and divide them like normal. So 7.1 divided by 8.2. And I'm going to go ahead and round to 2 decimal places since it's kind of long. This is approximately, since we're rounding, 0.87. And then when we are dividing powers, we subtract our exponents. So 6 minus 1 is 10, or 6 minus 1 is 5. So we want 10 to the 5th power. And then at this point, now we just need to correct it so that it's 8.7 instead of 87 hundredths. So I want 8.7. Originally, we would have had to move it 5 total. Now we'd only have to move it 4 total to the right, since we already moved it once to the right. Okay, last type of example on the back side of your homework is power to a power. So we're going to take a look at number 9 here. And you're going to distribute basically. So this would be 6 to the 3rd. And then when you multiply powers, when you take a power to a power, you multiply your exponents. So that would be 10 to the negative 15th. 6 to the 3rd is 216. But now we'll need to correct this to put it in proper scientific notation. So instead we want 2.16. Originally we would have had to move this 15 to the left. We've already moved it twice to the left, so we can change that to 10 to the negative 13th, okay, to fix it. So that's how this kind of ties into our exponent rules. And then you have an example of one of each at this point. So you'll want to continue. This worksheet, we're doing both sides. The front is easier if you want to go back and do that first. It's up to you.